Welcome to our introduction video for how to do an acid-base titration. This is, of course, just an introduction to the technique of titration. You could apply it to any sort of titration, including a redox titration. But I want to point out the equipment we have. I have my ring stand set up with my burette clamp, and I have all the rest of the equipment out, and I want to introduce you to the burette. It is a very long glass tube. It is glass, be careful with it. And it has graduates all down the side. Okay? And then we've got the valve here. And it's very important that you understand the way the valve works. Just like with the gas lines, parallel is on, perpendicular is off. Time and time again, students mess up titration because they get very, very close to what they want, and they go to shut it off and they get so excited they twist so hard that it like rotates around and stays open. Or they twist it the wrong way, and instead of closing it, they open it even more. So be very, very cognizant of the direction of the handle. Perpendicular is off, parallel is on. Right? Now the graduations are interesting in that this obviously goes up to 50 milliliters, tells us right there. Notice this, the 0 mark's at the top. So the 50 mark is way, way down here. Here's the 50 mark here. It is intentional that the numbers get bigger as you go down. That is to make the subtraction of final minus initial always come out as positive, which is very important to that calculation. So you're reading to the bottom of the meniscus, but you're reading going bigger down. Just be careful about that. And I point out this particular graduated cylinder is measured to the ones. The lines mean tenths, which means you will be measuring to the hundredths. So when we get to the point where we're measuring, be sure you measure to the hundredths. I'll say more about that in a moment. But let's talk about cleaning this out, because of course you don't want to assume that it's clean. It most certainly doesn't have to be clean coming out of the storeroom, because other classes have used the equipment. So we're going to start by putting some water through it. And for that, of course, the sink, the faucet and the sink just really don't work well. So all you need is, with an empty beaker that was also cleaned, just fill it with some water. You don't need to fill it any particular level, and let some of it run down through the stopcock out of the tip to wash the tip. But there's no reason to sit and wait for this to all drain. That's going to take you forever. Close the stopcock, twist this around, and let the extra pour out the end, and now the whole inside container area is clean. Oh, but we have water trapped up here in the tip. So you want to be certain to open the valve and let the water also drain out of the tip. So now it's been rinsed, it is clean, but check out all that water that is stuck inside the tube. All those little drops of water stuck inside the tube really will add up to a large amount in the end. So with items like burettes that are long and skinny, we do 2 washes. We wash first with water, and then we're going to wash with what we're going to fill it with. In this lab, we're going to fill it with base, so I'm going to wash it with a little base. I have over here my base that I'm going to be using in the lab, and I'm going to, with the valve closed, I'm going to fill it with a little bit of base. Not fill the whole container, and I'm pouring slowly so that I don't spill, but I might add maybe 10 milliliters of base to it. And just like washing it before, I'm going to swirl this around, maybe even let a little of it run out the end. I'm most certainly going to, over the sink, open up the stopcock and let some of it drain out through the tip there. And since that's going to take forever, I'll again just dump it out the top again. But I will again open up the valve to be sure that it has drained out completely, even from the tip. So now that it's drained out completely, I want to point out there's still a lot of liquid in this cylinder. Okay. Lots of droplets of water all over the cylinder, but it's droplets now of base, and I'm going to put more base in here so I don't have to worry about diluting anything now as I add my base. And that's why we rinse burettes and other things that are long and skinny twice. Once with water, once with base, or whatever we're going to be putting in. So now with my valve closed, okay, see my valve closed. With my valve closed, I'm going to put it in the stand, and all I do is I pinch this open and I set it in between the little fingers there, and it holds it just fine. And that's really tall for me, so I'm going to lower it down to make it accessible. And I'm going to take the base that I've previously measured out, and I'm going to very slowly pour that in. Now, how much base do I need? I don't know. I need enough. So I'm going to go to like 2/3 full, something like that. That's probably enough for this lab. Someone who has done a lab before would understand how much exactly you need, but since you've never done the lab before, you don't know. And so you just fill it to a good amount like that. Here's the problem. That fills the cylinder part, this part above the stopcock, but it doesn't fill the tip. Yet these measurements are meant to be measured when there's stuff in the tip. So I'm going to pour a little of this out through the tip, something like that. Got out some air bubbles while I was at it. And now I am ready to go. Now, why did I put the base in the burette? Well, that's because the base is the known in this lab. I know the concentration of the base in the beaker, and so I know the concentration. We always put the known in the burette. So that's my known. I know that concentration. My unknown is the acid. I don't know the concentration of the acid. That is the molarity or the moles per liter of the acid. That's what the point of the lab is, to figure that out. But right now I have rinsed the burette with water, and then I've rinsed it with a little bit of base, and I dumped that out, and now I filled it about 2/3 full of base, and I'm ready to take my first measurement from the burette. So I'm going to bring you closer. Hold on. It's going to be a bumpy ride, I'm sure. I'm going to take my first measurement, and it might help to see the meniscus by holding something white like the back of your lab paper behind it, whatever you need to do. Now I'm reading to the bottom of the meniscus, but I'm reading to the bottom of the meniscus with the numbers going bigger down. So here's the 13 line above the meniscus, here's the 14 line below. It's going to be 13 point something. And I can see from here it's going to be 13.30. Because the little lines go to the 10th place, I will estimate to the 100th place. So 13.30 is what I would write down on my lab as my initial volume. All right, so I've taken that one easy to take, very important measurement. Now I'm ready to set up for the titration that is actually the point of the lab. So I'm going to take a flask. I'm done with my base. I'm going to move that out of the way. I'm going to take a flask that is clean, and I'm going to add my measured amount. So I know the volume. I do not know the molarity of this acid, and I'm going to add that in. It is my unknown because it's unknown concentration. It is known volume, but unknown concentration. So my acid's in my flask, my base is in my burette, and I need an indicator to let me know when I've reached the equivalence point. So I'm going to use phenolphthalein. And all it takes is like a drop or maybe two at the most of phenolphthalein. No need to go overboard. And look at the magic that has occurred with adding the phenolphthalein. Yeah, you're right, nothing's occurred. But it will change eventually. So I'm going to set this up. That's a lovely sound, isn't it? I'm going to set this up with some white paper underneath just to make it easier to see the magic that would happen to this flask when I reach the end point. I have read my initial amount of base. So I've already taken my initial measurement from the burette. I have my unknown and indicator in there, and students quite often, unfortunately, put in their acid and forget to add the indicator. And then after 90 minutes of titrating, they go, why isn't anything happening? Well, because the only thing that's going to change things colors is not even in your flask if you don't add it. So be sure you add your indicator to the unknown acid. Yes, nothing changes at the beginning, but it will tell you when we've reached the end. And that's the point of what we're doing. So I'm going to get you closer. Be ready for a bumpy ride. Here we go. Much closer to where the fun is going to happen. I have my flask, and I'm on my own, so I'm going to do this with both of my hands. If you have a partner, you're welcome to split it up, or maybe just have one person that you trust do it with their hands. But I'm going to swirl my flask, and I'm going to slowly, drop by drop, add base from my burette as well. And again, I've taken an initial reading from my burette. I've read way up there. I've read how much that is going to be. So I'm going to slowly open the stopcock until I literally get drop by drop going. I don't necessarily want faster than that. Sure, I can speed it up, but there's really no point in speeding it up. This will not take long. So drop by drop, and as I'm dropping, I'm swirling. And you're like, ooh, this is so much fun. Well, just get over it. Okay, just swirl and drop, swirl and drop, swirl and drop. Okay, now I'm starting to see something happen. So I'm going to stop swirling so that you can see what I'm seeing. Do you see kind of a pinkish tinge happening and then disappearing? That's telling me I'm getting closer to my end point. That is the point at which the indicator is going to change color entirely. So I want to be sure as I start seeing more and more pink to go slower and slower. It will literally be one drop difference between that pink appearing and disappearing and it's staying permanently. So drop by drop. Constantly swirling. Oh, the pink's staying longer. I'm getting closer. Oh, it's almost there. Drop by drop, here I am. And it's going to fool you. You're going to think it's there, and then you swirl, and it's going to go away, which is why you should always be swirling. Oh, look, I think it's pink. Nope, it's not. It's gone. Oh, no. Okay, well, I'm very close. I'm going to add another drop. And I think it's pink. And I swirl, and it's gone, so I'm going to add another drop. And look at that. It is most definitely pink. It does not disappear even with swirling. I'll zoom in a moment. Look at that. That's what I'm looking for. And so at that very moment I see that that pink is there to stay. I'm going to stop the stopcock and I'm going to take my final measurement from the burette. So again, we're about to fly. Hold on. So up here, and again, I'd put a piece of paper back here if I need to. Up here, I would take my next final measurement, and again, it's going to get bigger going down. In this case, it looks like it's 24.60, and that would be my final measurement for the amount of the end mark and volume of the base. And then I can do some calculations, which is the point of this. Now, while you're here, I want to point out what could go wrong. Well, let's say, as I've mentioned before, that you get all sorts of happy with the stopcock and you don't stop it in time. It is possible for this pink to actually become a very purple color. So you really want to try and get it right when it's barely pink and avoid the purple. Now, sometimes it's unavoidable. I mean, like literally one drop difference could be the difference between nothing staying and a purple staying, and then you're okay if it was really one drop. But if you accidentally twisted the wrong way and too much got put in, then you really need to start over. And starting over is not that bad. You just clean out your flask and get some new acid, and you double check that you have enough base in the burette and refill it if needed, and just take your measurements and do it over again. So you can see in my case, it really doesn't take that long a time if you know what you're doing. With practice, it's a very, very good technique that's very common because it can tell us a lot of information for an unknown. It can tell us that concentration with an easy calculation, and It's a simple lab setup. It doesn't need that much equipment. It doesn't take that much time. So titration is really, really important. Even into AP, we do a lot of titrations because it's on the AP test often. And we'll even kick it up a notch with doing a redox titration. And I know that sounds all big and scary. It actually is really not. We have a different indicator in there, so we look for a different color during the redox titration instead of acid-base titration. That's what you're expected to be able to do tomorrow. So this was your introduction on how that all happens. Now, how do I clean it up? Well, this is all ready to wash down the drain, because if you know acids and bases, you know acid and base makes salt and water. So that's really pink colored salt water. Now, yeah, there's some phenolphthalein in there. That's why it's pink, but that's not that harmful to the environment in the amounts that we have used. I wouldn't drop a tanker truckload into the environment if I could avoid it, but certainly the 2 drops in my flask isn't going to matter. And then we do have extra base in this burette. Well, before I clean it out, of course, I'd want to dump the base into the sink, and then I'd rinse it with water. And what's really nice after you've rinsed it with water so that it's ready for the next class is to open the valve to be sure air can get through the stopcock as well, and clamp it here upside down so that it's dripping out ready for the next class, because it's kind of dry by that time, and then they can rewash it twice and be good to go. All right, that's what I expect you to be able to do tomorrow. That's what the lab's about. Good luck.